when we are dealing the work in terms of physics, it is actually a physical work. We have to consider a physical work as a work, not like reading a book and something like in a sitting position is not the work done in terms of physics. So here we are talking about a physical work done. Work is said to be done only when the applied force is able to produce a displacement. So there are two things here. We shall apply the force. If you don't apply the force, we cannot say work is done. We shall apply the force. But not applying the force is sufficient. This applied force shall be able to produce a displacement. Say for example, you are having a big wall. Against that big wall with your hand you have applied a small force, but there is no motion of the wall. Wall remains in the state of rest itself. Then the work done is equal to 0. Physical work is said to be done only when the applied force is able to produce a displacement. If the applied force is unable to produce any displacement, then the work done equal to 0. Work is said to be done only when the applied force is able to produce a displacement. Let us consider a situation like we are having a body whose mass equal to m, who is in the state of rest, and we have applied a force F. Let the body has moved to a distance S. We can calculate that the displacement S equal to ut plus half at square. Being the body is in the state of rest, I can write S equal to half at square. So after some time, it will have some displacement. As this applied force is able to produce some displacement, we can say work is done. So work is said to be done only when the applied force is able to produce a displacement. For example, we are willing to pull a suitcase on a platform. Let the mass of the suitcase is equal to m. Generally, we apply the force by making an angle theta with the horizontal. We cannot lie down on the floor of the platform and pull the suitcase. We are generally applying a force with an angle. And we can resolve this force into components. If you observe, the force is acting from the origin away from the origin from the point. Then we can say, basing on the triangle, we can resolve this force into components. And you must be clear that the components, it is called x component, it is called y components, shall have the direction always similar to that of the original vector. Our vector is moving away from the origin, and hence the components are also moving away from the origin. If you imagine a right angle triangle, we can write something like cos theta equal to fx by f. That implies horizontal force fx acting is nothing but equal to f cos theta. And we can also write sin theta by drawing a right angle triangle also there as fy by f, basing on the definition that sin theta is opposite side by adjacent side. From that we can write the y component fy equal to f sin theta. If you look at the diagram, it is very clear that this y component fy equal to f sin theta is trying to pull the body in an upward direction. But our body is no way moving in the upward direction, rather it is getting displaced from that position to a new position by covering a distance s. So it is very clear that entire force is not contributing the displacement. Only a component of the force, that is fx, that is f cos theta, is contributing for the force. Therefore we can write work done as the product of the component of the force who is causing the displacement and the displacement. So work is said to be fs cos theta. This is called the dot product of two vectors as for the vectors, and we can write work done as f dot s. Dot product of the two vectors means they are the two vectors, but when you multiply them, you are not going to get a vector, rather you are going to get a scalar. Work done is a scalar quantity which has only magnitude but no specific direction and doesn't satisfy the vector laws of addition. Work is said to be done only when the applied force or a component of the applied force is able to produce a displacement.